Don't worry, switch.
Horrible. All right, Ava, feel better soon.
We're done. That's cool.
What? Oh, yeah, so you're aware, Ava, we're doing this lesson as 2 days, so that's why the homework tonight is only 39 through 45. So don't stress about other stuff. No, just for tonight. If you want to go beyond that and start on what's going to be tomorrow's, then
What? I don't want to have homework. No. No.
So auxiliary lines have already been drawn, right? Anything else anybody thinks we should do?
Oh my god, I just wrote down it was 2014.
I mean, we could put in more values on the auxiliary lines. Like, we know that certain values, we know that half of it is 6. The other half is 6. I don't know.
The wall thing. It's faulted, guys. We're all gonna die. Hopefully. Mr. Hudson, we should play some relaxing Beyonce.
Gosh.
Nah.
Okay, well, I'm gonna lay here and die if we don't.
Do that somewhere else.
I'm going to actually die. If,
Come on, Ben, we have to talk about this square.
no, ew.
We're going to talk about the square.
I'm doing the homework.
I think we can find
Hi.
one of the sides by using by using trig.
Oh, you're on the wrong page, Gunner. Okay, why, Gunner?
Because I want to go home with homework.
So you already know how to do everything we're about to do. Please, teach yours. Dude, not cool. Like, I give you guys a ton of freedom, a ton of trust, and I don't really check on what you're doing. And you're going to just straight up, what are you doing? I'm going to do the homework. Not cool. If you just want to do the homework, peace, go to the library. But, like, okay. If you don't need me, sure.
So you got 2 ways to do it. And you do hexagon.
I mean, real offer. If you feel like class is unimportant and you don't need this, you don't need to be in here.
I'm using that paper that makes it really easy. Okay, this is a hexagon. It doesn't look good, but it's a hexagon. Oh, you think yours is Jenny.
Who's there? Who's got both?
First square. Got the first one.
Square for both.
Like both got both for A and B.
One for
So those auxiliary lines in A, what do those make? Ooh, isosceles. Okay, and if the right angle's here, means that my edges of my square are my hypotenuses. Hypotenuses. I'm pretty sure it's actually like you say hypotenuses. It's probably wrong. Goldring was in here and I was kind of looking at her hoping she would ring in, but she was distracted. So how do we figure out our edges then? Owen?
You and Jenny both do the same thing. Okay.
Well, I'm sorry.
What did I do?
You call me Gunner and you call him Owen sometimes. Sorry.
Because I yell at you both.
Aubrey on a crate to the office. Like Aubrey.
So what I was gonna say is that one of them that you can do is you can find the area of each individual triangle, but you can do it easier by doing 6 times 6, which would be divide it by 2, which is finding all the triangles, and then multiply it by 2 and multiply it by 2 again. But I did it like that because you could just, because it'd be equal, you put it as 6 times 6 divided by 2 times 4, but 4 is equal to 2 times 2, because I was trying to emphasize that really you could just multiply 6 by 6 by 2 to get 76, because dividing by 2 and multiplying by 2 cancels out. So you get the area equals 76 units squared.
So what I'm hearing you say is if I want to solve one of them, it's just half of the 6 times the 6, because that turns into base and height.
Yeah.
So 3 times 6 is 18.
Times 4 is 72.
Times 4. And our area,
I have a second one.
72. Yeah, and I was about to ask, well, what if we have to solve perimeter then? So your second method might take us to no perimeter too. Go ahead, Jen. Or
So I used Pythagorean theorem.
okay,
It's,
because we have 2 legs.
yes. And
So
then,
a squared, b
6
squared.
So I do 6 squared plus 6 squared equals x squared. Back up x. Replace the 72 with x squared, please.
Can I just extend it?
No, x squared. Okay, and then 72 equals x squared. Okay, since we know x is one side length and x squared is the area, we have 72.
Ooh, oh, I like that.
See, this is why you have to.
Actually, yeah, you're 100% right. So, that is an extension that I wasn't quite expecting. If we know that we're solving for x, that's a way that I hadn't really thought through. X squared is your area. Colin, you with me? I want to make sure we all see this right. Because we all can solve this different ways. It's all how you look at it. But don't work harder than you need to. By Jenny using Pythagorean theorem, she ends up getting the hypotenuse squared. Well, the hypotenuse squared here is the area. That's really efficient. I like that. All right, now the hexagon, though. Ideas? I'm going to go random cards. Yiga, got any ideas for me?
Well, we know the side lengths are 8 since it's
You
negative.
know all the side lengths are 8. And I'll label a couple more just to make that evident.
Excuse me, could I please have Caleb Smith to the office? Caleb?
Chris, any ideas?
I'm not really sure, but couldn't you just split into 4 triangles and 2 auxiliary lines crossing each other in the middle?
4.
If you do that across and then do the other one, you could get 4 triangles.
Those aren't triangles.
Yes. No, it's two triangles and 2 opposites.
You're drawing cube.
Oh wait, and if you do it again on those 2 sides, you get 6 equal triangles.
Hey, 6 equal triangles. Sweet. So now we just could find the area of the triangles and multiply by 6, right? Okay, so how do I do that? Jen? Well, if you want to skip, I'll come back later. Colin? How do we find the area of those triangles?
Well, we can, so around the point in the center is a total of 360 degrees.
Okay.
And there are six equivalent triangles all going around, all touching that point with like one vertex. Therefore, the angle measure of each of those should be 60 degrees.
Took the interior 360, divided it by the triangles.
And then if we do the thing we did yesterday with the exterior angles, we can find that all of the exterior angles of or all the angles of the inside of the thing, all the vertexes are equal to 120 degrees without the triangles. So divide by 2 is 60 degrees.
So you're
equilateral triangles with the side length of 8.
So hold up, by the same principle as what Colin just did here, yesterday we proved the sum of the exteriors is always 360, right? And since all of my exterior angles here are going to be congruent, we actually know that that is 60. So then Colin said this must be 120. Since these are splitting, they're like bisectors, each of these is 60. Are you with that? Everybody with Colin? Okay. So from there, Mr. Tepper, go ahead.
I solved for the area of each equilateral triangle by splitting it into two congruent 30, 60, 90 triangles. And then I solved for the length of the long side of said 30, 60, 90 triangle.
How do you solve for the length? So if you split it, then that's 4. And I guess since it's a 60, 60, 60, then we also know all the side lengths of the triangles are 8. So the hypotenuse becomes 8. How'd you find your long leg?
Short leg times the square root of 3 or 4 times the square root of 3.
And radical 3 is kind of awkward. You're going to get some fun decimal, but you could actually leave it like that, plugging it into your calculator. So that's your height, half, base of that. Now that is only one of those guys. So then when we solve that, what do we have to multiply by?
2 and then multiply by 6.
Yeah, we'll just do 12.
Wait.
So you can just do it together if you want.
If you just take off the 1/2, then you have the area of the entire equilateral triangle.
If you take off the 1/2, then it's this whole triangle. But be careful when you start manipulating the formulas, you've got to pay attention to what you're doing. Because now we're not using the straight triangle area formula. We kind of are, but we're doing half of the 8 times the height. So it depends how you look at it, how you want to solve it. What's your area come out to be here?
It's a really, for the total?
Yeah, give me it to the hundredths.
Yeah, it's really ugly number, but about 166.27.
Yeah, in radical form, if you left it there, the 96 radical 3, which that would be perfectly fine. If we round to the tenths, sorry, I forget what we said for the hundredths place. 2/8.
2/8.
So does finding that long leg by setting up the special right triangles, does all that make sense? Any questions? Try your next problem. I think we all probably would take the same method on the hexagon. I'm wondering about us just moving on to 35. So we could deal with the other shapes. You can make a whole lot of shapes inside those. Best thing to do is deal with the triangles. Let's look at 35. We might cycle back to 34 later. I want you guys to spend a fair amount of time working through all 3 of these, because they each give you something different. Be careful with the difference between A and B.
How much is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not big point. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. That's a 9. What'd you say?
He said something secretive. That's why she whispered.
I'm going to type on your testing this week, so Dexter's gonna be laughing. Oh yeah, Chinese New Year.
Okay, so Jenny, I'm gonna. So what do we?
Oh, let's see. Oh, Betty.
Here, can you draw for me, though, please? Actually,
Oh, I took this ball.
well, I need to draw because I think I know how to solve it. I think I know how to divide it into triangles.
As you're confident with your solution, if you want to come and write it up on the board, I would welcome you to. I encourage you. If you want to check your answer first, I will happily do that. Or are we board shy?
Figure out how to draw the shape. Drawing is hard.
Draw what shape?
The first one. And slow workers, we work hard, and that's what counts. Effort.
So I think the issue you're having has an odd number of sides, which means your transversals can't go straight through.
Yeah, they do. They don't.
There's a point
1,
at the
2, 3,
top
4, 5,
and not
6,
at the
7,
bottom.
8, 9. 1, 2. Oh, yeah, they don't. Okay.
So your transversals aren't straight. Like straight through the center. They only go from center out. So we have a nonagon. Once we get beyond 8, I just write the number.
I'm gonna write nonagon.
No, you're good. You can write whatever you want.
I like words because it's good to know words.
Will anybody come up here and do this, or do you just want to talk me through it?
Sure, yeah. I can somewhat do it. I can do it to an extent when I have it on.
If you need to draw like other drawings and stuff, and then you can come out here, I can copy this page for the next one.
So since there's 9 sides, just 360 is divided by 9 to get 40, which means that this is going to be 40. These, the top thing
Or 4C.
Well,
This is not a good nonagon.
so those are all going to be 40 degrees because it's the 360 degrees total. And if I can that, the one, I don't want to go
Exterior angle.
that exterior angle, we can know that this is also going to be 40 degrees, and this will be 140. And then because of bisectors, each of these will be 70.
Everybody let this talk.
Wait, where'd you get the 140?
140 is the full angle.
What do you call the relationship between the exterior and the 140?
Supplementary.
Yeah, supplementary.
That's all I got.
So when you find that center angle, you are at the same time finding the exterior. Right? That's a really good skill to have in your back pocket. Of like, oh, I just did 2 things at the same time. So we now isosceles. When you have regular polygons, will they always be isosceles? Will they always be isosceles?
Regular
I think so. Well, at least isosceles.
So this is 11. Chris just told us these base angles are 70. Okay, top one's 40. where do I go from there? Okay, I'm gonna set this down for a minute and let you guys keep working. Trig only works with right triangles.
So we can make it into a right triangle, but based on size sector.
Oh. Yeah, that's. I already tried to make it minus triangles make it into like triangles. Yeah.
What's the side, like the edge?
11.
No, like the very edge.
What do you mean by the very edge?
Like this edge.
11.
The bottom.
Like the circles, like
Yeah.
the basic circle. Like
Yeah.
we don't know.
So we don't know anything.
We know a little bit.
Wait, can these trig?
We need to make it first into a right triangle, two right triangles.
I already did that.
I like how you phrased that.
Opposites over. Oh.
Hey, if you can't figure out what we want to do next in A, look at B. B's got a right angle in it.
I think I have an idea that is working for you, so I'm going to go through that.
Yeah.
No, you're wrong.
Gio, what do you think I should do next?
Power.
How? I don't have right triangles.
Well, just split it in two.
Oh, if I drop a
And then
bisector,
you sign.
I could use either. Because now I know that this is 20. So if we're going to use sine, what angle did you use? The 70 or the 20? 70, because we want to solve the opposite of it then. X over 11. Now don't round that. Leave it in your calculator and work with it. Sure, so that is your height. Wait, can we find area?
Yes. Well, we need to find the other leg, but once we do, then yes.
So when you said like, or use cosine, won't switching this to cosine switch? Hey, are you guys like trucking along on one of the other ones? I want to make sure that we're together. Okay, so you're good with like the sine and the cosine to solve the two unknowns? Okay, just checking. You can keep talking, you're fine. If I switch this to cosine, I'm now solving for adjacent, because then it's adjacent over hypotenuse. Or if I switch this to 20, so since you already have this in your calculator, probably 11 sine of 70, if I then go sine of my 20, I solve for that opposite. What is your base section that I guess we can call Z? What do you get there? Probably like 3 something. 3.7 something.
Oh, okay, 3.762225.
Is this making sense? Dropping the auxiliaries and everything. So, you know what's really convenient? What is Z? And don't, like, I'm not looking for 3.7, we know that. Z's half the base of the triangle that we have 11 of. So this is already half base. This is height. Boom times boom times. Yeah, 9. Sorry, I was on a different problem. times 9 gives us the entire area of the whole thing. Because this is half base, that is height. We have 9 of them.
Oh, yeah.
So,
I messed up.
we already have every single thing we need. We just have to multiply.
I got 30. I'm 70 plus that times, hold on. What was that?
No, not even close. My mental math is way off.
Oh, I got 349.
This is some rounding.
So you did
So that's what the book has, from some rounding.
You did 10.34 times 3.3.
They probably did 10.3 times 3.8. I'm guessing they're working in tenths.
Wait,
If you get it more exact, it's... So you said you had what?
349.
I got 345.139.
What, 45?
5. What were you rounding to? I'm just curious.
I just rounded.
To tenths or to hundredths? Or
I
what?
didn't round. I used the thing in my calculator.
Oh, so you like carried the precise values. Did you round or carry values?
I rounded to like the thousands.
Well, I made it more.
So 345 to 350, depending on your rounding. Try to beat. Decagon.
I don't want to draw this. I don't want.
I've been
What
using
do you want? But
I'm just not good at drawing.
really, you don't need to draw the decagon. You really just need one triangle.
Oh.
You got this figured out?
Oh, yes. Okay.
Ted.
That helped make that a lot easier. Thanks. What?
Thank you.
Yeah, I feel like you have to repeat that. Acknowledge yourself
I
on my
don't.
shoes. So my real question is, are you able to do the homework without having this lesson? If so, awesome. But I highly doubt it. Because these skills are kind of tough. Like jumps and figure out how to draw those transversals. And I was still working on this stuff in college. You guys are really impressive students. Normally you can't do the practice work when you haven't done the lesson yet. So can you give this a shot?
You know what I do, Jenny? Okay, so I found one of the triangles because you know already what it is with right angles. You know that it's 5, and you know. Okay, turn it towards us. Can you see this triangle is right here?
36 degrees per shape.
Yes. I divide 2.
So we got a 2 that's 18 degrees.
Yes.
Yeah,
So
good
the remaining
Good
one.
question.
Triangle.
And then
Yeah.
9.
Sorry.
What?
Don't say
72.
that.
Did you say?
Yes.
So we have this, right?
72.
We can make lots and
And then
lots
you
of
just
like
figure something.
Oh,
Yes.
Alright.
Oh, that's easy. I get it.
No kidding.
Really?
Oh wait.
You know how I got 18 degrees?
Opposite over adjacent side.
Alright, so you know how this inside part's a circle, right? And how much is this circle?
60.
Okay,
This
okay.
is like,
Oh,
remember
yeah,
I
and
have to like brush your favorite Mr. Problem.
Yep.
Because I thought that like 8 divided by
And
4
then you
was
have to
like
split the
5
triangle into two.
Yeah.
Okay. And I will sit back and let
X
I thought you just had
oh no, I didn't.
just told me.
that
Hey, do you want
times
to
2.
Well, I don't actually split this all.
Oh my god.
Plus 3.
Oh my god.
Actually, no, I'm gonna make it exact.
Oh my god.
2
Oh, why don't I just
5
5?
times
Okay, that does.
Oh my god.
equals
Not
that
now.
times 10 equals 81 point. What? 81.2 to 99.2.
What did you do?
What did you do?
I did it
Are
right.
you solving for the angle?
No, I solved for the whole thing.
Oh, okay,
Area.
sorry. You were looking at me earlier because what the number I'm about to write is 82.
I got 81.2292.
Wait a minute, I told you that.
Oh yeah, I just forgot. 'Cause I wasn't listening. No.
So interesting too.
Pretty fun.
What's
Sorry, 144, right?
Jenny has keys.
So, or for the sake of time, does everybody understand how to solve for the angles up here? Should I review the process? You solve for the center angle by cutting up your 360 by how many gon you will have. Your exterior angle is the same.
Did you know that gon is an airport name?
You looked it up.
No. We're doing the thing in global cultures. And I'm planning a trip for Miss Goldring.
Oh, you mean
right.
G-O-N is the airport abbreviation?
G-A-N.
Okay. Well, that's like saying CMH is an airport name.
Wait, what
It
is
is.
Yeah,
It's the abbreviation that's on the plane stuff. Like on the ticket and everything. Alright, so then you can take your 144, which is the supplement of your exterior, or you can find your 72 through just triangle angle sum theorem. That's another way to get there. Because this top angle would be 36, which leaves this small angle as 18. Through trig, which we already know that our height is 5, we can find the one last piece that we need. What do we need to solve for here? Yeah, we need to solve for the edge, right? The edge of the decagon. So, 72 or 18. That'll just change whether you sine or cosine. Anyone have a big preference? No one really likes sine versus cosine. Sine's first, so we'll use
I like sides because they don't know the way.
So I'm going, okay, that's not even funny. I can't wait till that goes away. I'm going to use sine, which means I'm going to find the opposite to the angle, so I've got to use my 18. Wait, I don't have hypotenuse. I'm using tangent. Wait, that's why I kept saying sine cosine. I was waiting for somebody to tell me tangent.
I used tangent, but I didn't do it wrong. I was checking if I did it wrong or not.
Oh my god.
I have tangent of 18 equals x over 5, and then tan 18 times 5 equals x to the bottom half the way.
Wait, tangent of 18 equals x over 5. So 5 tangent of 18 equals x.
Yes.
Make sure you're always in degrees, because it's just better that way. And x comes out to be
That's the one. I just kept like this tan of 18.
8.
I got it here, 81.22992.06.
Aren't we solving for this?
Oh, well, the total.
Oh, you guys are like 9 steps. I'm asking what the base is.
1.62 something.
So that's your half base times your height of 5 times 10, because we have 10 of the triangles, and we end up with an area of, now do that.
81.22992.06.
29.
2299.
229, so I'm just going to go 23. Hundredths is good.
Billion.
Have fun with that. We're going to pick up on C tomorrow. So you've got a couple minutes left to wrap up or start a homework problem or two. We're out of here in like 2 minutes.
I need to do it because
I'm still looking for some of your guys' chapter 7 homework.
You have mine right.
So I've caught up on my other classes. I'm coming for the math 2 papers that need graded. So. Ava, feel better. Thanks for watching.